Hi all, and welcome to the video on factorisation. We're going to be talking about factorisation with algebraic fractions, but just right at the moment let's just talk about plain simple factorisation. Sometimes factorisation is easier to think about if we think about it from the point of view of it being the opposite of expanding. So I'm actually going to start with this down the bottom, xy squared plus bracket y plus 1, okay? To xy squared times y plus 1. Remember, this means that this is multiplied by that. Alright, we've got two things multiplied together. So what are we going to do? We're going to multiply this one by that one, and that one by that one. That's how you do expanding. You multiply whatever entity is on the outside by the entity on the inside, by all of the entities on the inside. So if I did that, and I'm going to go backwards, we normally go forwards, but I'm just going to go backwards and write that that's going to be the same as xy cubed plus xy squared, because xy squared times y is going to be y squared times y, which is y cubed, and xy squared times 1 is just going to be xy squared. So if you wanted to, I could insert another line right in the middle here where I have these curves, just showing that. Now I wouldn't have to, I could go straight back to that step that I went to if I wanted to, but I could just show that what I'm actually saying down here is I'm saying xy squared times y plus xy squared times 1. That's what this line down here with the brackets actually means. And if I solve that, then I get that. So that's expanding. If we go that way, that's expanding. If we go this way, we are doing factorising. Alright, so with factorising, if you're not completely sure how to do this and you can't really see the factors, write out the expression with multiplication signs in the most expanded form. Multiplication signs in expanded form. So you might be one of those people who look at this and go, this example, and go, it's got an x, it's got an x, it's got y multiplied by itself 3 times, it's got y multiplied by itself 2 times. Therefore I can take xy squared out the front. That will leave me with y there and 1 there. You might be able to go straight to that, and if you can, that is absolutely fine. I want to reiterate that. If you're not completely sure how we got that, just do it in bits. So write out the expression with the multiplication signs and in expanded form. So we're going to write this as x times y times y times y plus x times y times y. Okay, so we've done our step 1. So our step 2 then is going to be circle what is common and put at the front. I'm just going to erase some things. Okay, so let's circle what's common, and then we're going to write that out the front of a bracket. Front of a bracket. Remember to copy these steps down in words so that when you look back you actually remember what we actually did. So I'm going to circle what's common just in a different colour. So we've both got an x here and an x there. We've got 1y there, 1y there, 1y there, 1y there. So I'm not circling this y here because I don't have 3 y's on both sides. Then I'm going to write that out the front, and I'm just going to get rid of the multiplication signs now. And also I know that I can write y times y times y is y squared. So I'm going to put x y squared out the front, and then in the brackets put what is left over. So that's step 3. In brackets put what is left. So let's put what it's left. Well, obviously we've got a y left here, plus, now it looks like we've got nothing left here, but we don't really have nothing, because if this is 0, say we said this was 0, when we did expanding and we did xy squared times 0, we'd get 0. And we don't want to, we want to get xy squared. So instead of 0, we're going to put 1, because xy squared times 1 is xy squared. That's a quick revision on factorising. Now let's do an example where we have a fraction, and we do exactly the same thing with a fraction, but we always factorise first using the steps on the previous slide. And you factorise first the denominator and the numerator if you need to. So I'm going to put d and m, denominator and numerator, and then you cancel. This is going to help us when we do multiplication and division. Multiplication and division, we factorise first and we cancel. So let's factorise. Now again, if you can go straight to what that factorised numerator is going to be, do it. But if you're not sure, let's write it in its simplest form. So I'm going to write it as y, 4 times y times y times y. Now instead of 8, I'm actually going to write 8 as the factors of 8, being 4 and 2. So 4 times 2 times y times y times y times y. And then 12 times y to the 5. That's going to be 4 times 3 times y times y times y times y times y. Alright? Divided by y to the 3, which is of course y times y times y. Now I can't factorise the bottom, obviously, because there's only one term. Remember, with factorising you've got to have more than one term, where a term is something separated by a plus or a minus sign. So with this one, here's my expanded form. Now why did I choose 4? Well, that's because I knew 4 goes into 8 and 12. With factorising, you are trying to do one very simple thing. You're trying to find the highest common factor. So what is the biggest number that goes into each of those terms? That's what you're trying to find. Write that one down. If, in our case, 4 goes into 8 and it goes into 12. 8 does not go into 4. So you want the biggest number that goes into both of those. Alrighty, so we've done our first step. We've written it out in expanded form. Now we're going to circle what's common. So if we circle the 4s, because there's a 4 in each term, then we're going to circle the y's. Now what's the biggest amount of y's? Well, there's 3 here, 4 here, 5 here, and I've got to be able to take the same amount from each. So I'm going to circle the 3 there, 3 of those there, and 3 of those there. So I'm only going to be able to take out y cubed. That's fine. So I'm going to take out and put out in front of my bracket 4 y cubed, and then put everything that's left over. Now remember, when I expand, I want to be able to get the same thing as up here. So I can't put a 0 here, I've got to put a 1, because 4y cubed times 1 is 4y cubed. Then I'm going to put what's left over in the second term, so that's going to be 2y, and in the third term it's going to be 3y times y, or y squared. And then I've got divided by y times y times y, or y cubed on the bottom. So I can just do the final thing now. I've factorised, I can cancel. So I'm just going to cancel the y cubed, and I'm going to be left with 4 as my answer. Alrighty, last example. This one is just a little bit tricky, and you just got to see a pattern. Go, well, how do I factorise that? Well, I want to be able to, if I've got a question like this, I must be able to do something. And to do something, the only thing that I can really do probably is try and cancel things. Now you might be going, why don't you just cancel the A's and the A's and the B's and the B's? Do that. No, don't do that. That's a really common thing that people do, and you can't do it. And the reason why you can't do it is that this little statement here actually means negative A divided by A plus B, take B divided by A plus B. That is what that statement actually means. So that negative A up here is actually divided by the whole of A plus B. That negative B is divided by the whole of A plus B. So you can't just cancel bits of it, because it's actually divided by the whole thing. Alright, so we can't cancel in that way. So to cancel, we must actually have to somehow be able to get rid of the whole of a plus b off there. A plus b is not the same as negative a take b. But can you see that if we took out, and by taking out, we often say take out, what we really mean is divide. If I divide this negative a take b by negative 1, alright, I would get negative a over negative 1 take b over negative 1, which is the same as a plus b. So when we take out, or we put that number at the front of our bracket, we're really just dividing each term by that number. So I'm going to take out negative 1, and I'm going to get left with a plus b on the inside, and that's going to be divided by a plus b. And if I cancel that, I get left with negative 1, and I'm happy. Alright, so that's just a quick video to introduce you to the idea of factorising with algebraic fractions. We're going to use that soon when we're solving some algebraic fractions.